right. So I learned a few tricks about this particular interface. Let me see if I can move it to another space so it doesn't interfere with the recording, because I think sometimes it just interfere with the recording. And I'll double check and make sure it's still, yep, it's still staying on this one being recorded. So I think we're good. The mic sets I'm good here. All right, so we'll go ahead and get started. Okay, so I'm hoping that between the time I sent you the announcement and today, that some of you had a chance to take a look at the questions, because if you took a look at the questions before today, then you would be able to ask more in-depth questions rather than just listening to me solving those problems. Because I have had many cases, not one, but many cases where people would tell me, when you explain it, everything is like crystal clear. I understood everything. When it's time for me to do it, it's like, how do I get started? So to avoid that situation, it is important that you get a little bit of head start. Try to work on these problems so that you can find out, okay, maybe I'm not quite understanding that concept, and then you can ask those questions in class. So that's why I sent you this file. You kind of like way ahead of time, so that you have some time to kind of look at this and try to come up with the questions. All right, so first thing is to read all the instructions. It's very important. This exam is an individual exam specific to the student with the ID stated above. So you're going to have to put in your own student ID here. No collaboration. It's paper-based, no electronics during the exam other than a scientific calculator. If you have one of those fancy graphing scientific calculator, you can use those as well. I'm not really sure how fancy calculators will be like super duper useful in this class. If you have all the basic stuff, basic scientific calculator. Years ago, I was able to find scientific calculators at the Dollar Tree. Like, yes, $1 for a scientific calculator, and even those would work fine. Okay, you just have to know what you're doing with your calculator. Okay, so it's paper-based. Do not share or discuss any parts of this exam with anyone in class or otherwise until the next class meeting, because some people may still be taking the exam late for one reason or another. Grading is based on the explanations and steps, demonstration of understanding of knowledge, and problem-solving skills, not so much the final answer. So that means you really want to be able to show me the steps whenever I ask, especially when I explicitly ask for steps. Sufficient explanation means your answer connects definitions and concepts discussed in class via logical and/or mathematical steps to find the answer of a question. So always start with what we have talked about in this class: definitions, symbols, and so on. Write your answer on answer sheets, and you might want to bring extra sheets of paper just in case you need it. So do we have any questions regarding the instructions, which is going to be very similar, if not exactly the same, for you on next Tuesday? Yes.
It's just about the answer sheet. Is it just one sheet of paper with like the questions typed out and we're just writing our answers? Or
so the questions are very condensed. So there's not a whole lot of space to write your answer on the question sheet. So you probably want to write all the answers on your own pieces of paper. I can supply some, okay, I just use a laser printer to print line paper, basically. So if you know that you have a particular binder or binder paper that you like to use, or your graph paper that you like to use, just bring your own paper. Yep.
So the test will be Tuesday?
Next Thursday. I might have misspoke. It's next Thursday. So it's 1 week from today. All right, so we'll go ahead and start with questions 1 to 4. So the instructions goes like this. In questions 1 to 4, solve for all unknown bits in a 1-bit subtractor. So how hard can that be? It's a 1-bit subtractor. Note that in the 1-bit adder or subtractor, bit 0 is the signed bit when interpreted signed. Okay, so that's important because otherwise people will say, Well, if we only have one bit, do we still have a signed bit? The answer is yes. The signed bit is the only bit. Use the 5-row format in your answer with the rows labeled X, Y, Q, T, and D. All rows other than T has 1 bit / column, whereas T has 2 bits / columns. Also include the overflow, OV, because I don't want to want it to be too confusing, because if it's just O, it looks like a 0. So OV makes it a little bit more distinct. And then the L flag is uppercase L, which also makes it more distinct compared to 1. You will be given known bits for each question. Figure out the value of all the other bits. The following are rules you can reference. In other words, this way you don't have to quote every single time and rewrite, oh, QI is XI exclusive or with YI. So I'm giving you, these A, B, C, D, E definitions just so that you can reference it. So whenever you can say, you want to say, oh, because of this reason, they just say, because of the following, blah, 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 is the result or the conclusion. Is that okay so far? So I'm giving you the basic blocks already. Show all steps and reasoning in your answer. For each step, state, okay, so I'm trying to do my best to explain what I'm expecting, which rule or rules are applied, what known bits are utilized, and what your conclusion is. So you have to show me all the steps. This is an example of the right format, but it obviously makes no sense. A, C, so those are quoting the rules. X0 equals to 0, which is probably given in the problem, because X0 is 1, and X0, D0 is 1, therefore D0 is a 1. So in this case, it has to do with conjunction. In order for conjunction to be a 1, both components of the conjunction must be 1. But you don't have to explain that really long thing. You just have to say that because we know X0, D0, which is the conjunction between those two, is a 1, and we also know that X0 is a 1, then D0 has to be a 1. You can utilize symbols or abbreviations instead of because. You can use B/C or the 3 dots with 2 dots on top and 1 dot below. That's the mathematical symbol for because. Instead of therefore, you can use thus, the implication symbol, and also use the math symbol for therefore, which is also 3 dots, but this time the 2 dots are at the bottom. Okay, so do we have any questions about the notations that you are allowed to use in this case? Okay, the questions, okay, yep.
If we do it in the other format, will be done.
Well, I'm trying to give you as many specifications as possible. Why would you want to deviate from what I already supplied and specified? I mean, as long as your answer is still consistent with what I have stated of what I'm looking for, I will not deduct points, but I'm giving you a whole bunch of suggestions already of how you can format your answer to a point where I go like, yep, this is the kind of format that I want. But the reasoning still needs to be there, okay? In other words, someone using exactly this format, but the reasoning is all bogus, that would still not get any points. Yes?
Not sure if I missed it, but can we assume that this is not being connected to another address?
This is not connected to.
And then like we're not.
Yes, each one is a standalone subtractor. Yes. Yep. You can also ask questions during the exam. If you feel that something is not clear in the questions and you just want a clarification, those questions I will definitely answer. In fact, you can ask any question. Anyone can walk up here because I don't really want to walk into the aisles, back there. So you can come up here to ask questions. You can ask any question. I may not answer some of those questions. For instance, if somebody were to ask me, what does this symbol represent? I go like, well, the test is trying to assess that, so I cannot answer that question. Or if somebody asks me, so can you tell me again what is exclusive OR? Same answer, I cannot tell you, because that's what the test is trying to assess. Does that make sense? So, but if you just, want a clarification, like what, you mentioned earlier, that's perfectly okay. So you can always ask. It's just that I cannot guarantee that I can give you the answer. Is that okay? Yep.
Are you gonna be giving us an answer sheet, or are we gonna write it on our own?
You are going to write it on your own piece of paper. Mhm. So bring your paper, bring your pen, pencils, and other writing instruments. Yep.
So, I think you mentioned this already, but is the exam open notes?
Yes.
So long as our notes are on paper.
It's- You can bring anything that is printed or handwritten on paper prior to the test. And that you can use it. So you can work with people. You guys can have study groups, okay? It's a super long weekend because tomorrow is a holiday, so it's Monday. So you guys can have a study group. You can all bring in exactly the same written stuff or printed stuff. It's okay with me, not a problem. And you can bring in as much as you want or as little as you want. There's no one-page requirement, or you can only have 5 pages. Okay, the only limitation is physical. Can you really bring all that stuff with you and have the space to kind of put all your stuff? That becomes a physical limitation. I think beyond a certain point, it's not gonna help, okay?
Where will this exam take place?
When?
Where?
Where? You'll be in this room during the lecture time. So 1 week from today, in this room, we're gonna have exam 1.
So it's only lecture hours, like we have only 1 hour.
We have 80 minutes. It starts exactly at 5:30 and it ends exactly at 6:50. Yep.
Yeah.
I will be in the lab. I will answer questions regarding the exam in the lab. So if there are if anyone wants me to explain those answers, I can answer those in the lab. All right. Any other questions? Yep.
Will you post the solutions after the exam?
Can I?
Post the solutions after we take the exam?
I can explain the sample answers, but I cannot give you your exact solution.
Oh, there's gonna be different versions.
Oh, there'll be many versions.
Oh,
I think there'll be as many versions as there are students in this class. But generally speaking. Yep, all right. So are we ready to move into question number 1? Okay. Yep.
So in this example, is that the final answer, or we should actually write the table afterwards, like X, Y, T, U?
This is just the question.
Yeah, in the answer.
In the answer?
Format, or we actually have to write the table, like X, Y, T,
I'll show you what the answer is going to look like. That's the whole purpose of today's lecture. Is for me to demonstrate, what I'm expecting and how to answer those questions. All right, so here's question number 1. Question number 1 says, the known bits are D0 is a 1, T1 is a 0, and then you need to figure out the rest. So first of all, you have to find out, okay, what do you mean by the rest? Okay, this is a single bit subtractor. So what bits are we supposed to figure out? So that would be the first question. And I am going to, okay, which way do you want me to write the answer? Because I can do the freehand writing thing. I can use Joplin, or I can just use Notepad, which is fast, but you won't see the math notations. It's up to you guys. Joplin? Okay, we'll just Joplin. All right, so here's Joplin. Let me switch to today's lecture. Today's the 16th. All right, so it's Joplin. All right, so I'm going to handle question number 1 first, and I'll just go ahead and copy and paste this entire question, then we can work on it on the other side. And switch back. Paste. There we go. Probably want this to be on a new line like that. There we go. Okay. All right. So how many bits do we need to specify? So we have, x0, y0. We have q0, t0, d0. Then we have t1. We have the overflow flag. We have the B flag, which is easy. Okay. And then we also have one more, which is the two more. Actually, we have the sign flag and then we have the L flag. So these are the ones that we need to figure out. We are given only two, and we need to use these two, B0 equals to 1, T1 equals to 0, to figure out the rest. Okay. So how do we get started? Oh, and I also need to remember to paste the rules because I can quote these rules instead of rewriting everything from scratch. So I'm going to copy and paste that too. So copy, and then we'll paste it right here. There we go. All right. Yep.
So, for rule number 8, I have in my notes that Q equals XI, sort of YI, not TI. So, my notes are wrong, right?
Say that one more time, sorry.
I have QI as XI, or YI.
Yep.
But up there it says TI for rule A.
Oh, that is incorrect. I got it wrong. It's XI exclusive or with YI. You are right. Definitely wrong. So the correction is right here. This is supposed to be YI and not TI. All right. So how do we get started here? How do you get started? Okay. In other words, if this is the question that you get, even without taking this class, okay, and I'm giving you all the equations with A corrected. So how do you get started? You start with what you already know, which means you look for things, you look for equations that has D something on the left-hand side of the equality, or with Ti plus 1 on the left-hand side of the equality. Does that make sense? Okay, so there's a method to this, right? So you basically start with what you already know, which is these two particular bits and also the equations, and then you try your best to go like, okay, so given that D0 is a 1, what can we use here? How useful is it? So we can start with this one. So if D0 is a 1, we know Q0 exclusive or with T0 is going to be 1. Which tells me they are different. But other than that, I don't know which one is a 1 and which one is a 0. So I have 2 degrees of freedom, and I cannot quite figure out which one it is. So for the most part, the T is actually the most useful one. Okay, knowing that T1 is a 0 means that applying rule C, we know that when I equals to 0, that whole equation ends up as a 0. So I'm going to start with that one. That one seems to make more sense to me. So in the explanation, I'm going to say T1 is a 0 means, okay, using rule C, means not x0, y0, or not q0, t0 is a 0. Is that okay? So I quoted a rule, and I started off with something that is given to me, and now I have a conclusion. The conclusion by itself is not the answer, but it's one step closer to the answer. Because the conclusion is I have a disjunction that is false. So in return, what can I infer from not x0 and y0, or not q0 and t0 is false? What can I infer from that? They're both false, right? Very good. So therefore, not xi, not x0, y0 is false, has to be false. And not q0, t0 also has to be false. Is that okay? So I'm explaining my reasoning here, okay? My reasoning is based on the truth table. Because in the truth table, the only time a disjunction or ends up with a zero is when both sides are zeros. So that's a lot of information because it locks down the two conjunctions must be zeros. Both of them must be zeros. Okay. I'm not really sure why it is highlighted. It's probably because of some syntax, markdown syntax. So I'm going to bypass all the markdown syntax by putting these in both in code blocks. There we go. Okay. So now what can we do? Let's see. Well, out of those things, out of the T0 thing, T0 is known to be, we don't know what it is, but we know what D0 is. And D0 is a 1. So what can that, how can that be helpful to me?
The relationship between Q and T.
The relationship between Q and T. Very good. Okay, so you said zoom here? Sure. So let me go to view. Is that okay? Okay. Yep.
Is there a reason we didn't use the B formula first?
The what?
The B formula,
The B formula.
the one that's the B. Borrow?
The
No,
borrow.
The one, like you, like formulas labeled for the test.
He's talking about your list of most.
Oh, the borrow. Oh, the borrow is the T.
The DI is QI X one TI.
Don't know what order it is, 0, 1, or 1, 0.
But you
And we
know
also know TI. We know TI plus 1, but we don't know.
TI is always 0.
Yes. No, there's no assumption about T0. So T0 is an input. So you cannot make assumptions about T0. Is that?
We have T1, not T0.
We have T1.
Yeah,
and
Yes, we know what T1 is, and that's why we can make this conclusion so far.
But don't
and-
we always know that T0 is?
No, we cannot make that assumption. So it can be stacked. It can, so T0 is an input bit. Sorry, so earlier I said, it is not stacked, but T0 is still considered an input. All right. Yep.
It's not specified, we assume that it's 0.
No. Do not make any assumptions. So you only know about the known bits, everything else is unknown. All right, so now we managed to conclude that not x0, y0 is a 0, not q0, t0 is also a 0. But we know that d0 has something to do with q0, t0. So now we say d0 is known to be a 1. That's given to you. Okay, this is not something that I worked out. This is something that's given to me in the question itself. So this implies, okay, I'm using that as implies. It implies that either x0, oops, sorry, not x0, but q0 is a 0, t0 is a 1, or q0 is a 1, t0 is a 0. Okay, so let's, and I'll put in the correct both logical operator here, just to be clear, extra clear. Okay, does that make sense to you? The fact that I know D0 is a 1, then I know, between Q0 and T0, one of them has to be a 1 and the other one has to be a 0. Yes.
So wouldn't you want us to put down the rule B under that because we're using
Yes.
rule B for that?
Yep.
Or are we-
Yep. So you have to quote the rule. So the rule that we need to quote here is which one?
Bravo.
It's going to be B. Because rule B tells us, how D of I is computed. Does that make sense?
Yeah.
All right. Okay, so now that we know rule B is being used, do we understand why one of these two conjunctions has to be true? Because that's the only way for the exclusive OR between Q0 and T0 to become a 1. Are we good so far? Okay. So between these two, we know one of them for sure should work, and then the other one should not work. So we just have to test it. So let me go test the one that should not work, okay? So then we go like, okay, test case 1. Test case 1, which is DQ0 is a 0 and T0 is a 1. So if that is the case, okay, this is an assumption, then not Q0, T0, and T0 in this case would have been a 1 contradicting that T1 is a 0. Okay, so I'll pause here and scroll up and see if you guys understand what line of reasoning I used in this case. Yes.
You have to say it like that, or could you say because not Q0, T0 is a 0, thus it's the other?
Yeah, you just have to make the connection. You have to say, if Q0 is a 0 and T0 is a 1, then not Q0 and T0 would become a 1, and that contradicts what we had earlier. Because we made a conclusion already that not Q0 and T0 has to be a 0, because otherwise T1 would have been a 1 and not the 0 that we have given them. Is that okay? So this line of reasoning, there's a name for that. It's the elimination of possibilities. Okay. Now, in general, if you need to eliminate all the possibilities except for the one answer, it is painful. Because in general, you have many, many options to consider. But in this case, you only got 2 options. It's very easy. If this one doesn't work out, it has to be the other one. All right. So it's a very feasible way to apply the elimination technique. All right. So the conclusion of this is conclusion. So I'm just using extra words here. You don't have to use as many words. So the conclusion is Q0 is 0 and T0 is a 1 cannot happen. Well, if that cannot happen, we only got one more choice, right? Because we know between these two, one of them has to be true. So that means the other one has to be true. So this means Q0 is a 1 and T0 is a 0 has to be the case. Okay, and in fact, we can plug in. So we can say, if I negate Q0 and T0, it becomes the negation of 1 and 0, which is also 0. Okay, and this is consistent with T1 being a 0. Okay, so now we have locked down quite a few bits. Okay, we have locked down which bits. T1 is given. We have figured out what is T0. It has to be 0. We also know Q0 is a 1. So what is left? Well, we got a few things left. I will try to figure out the XY first, okay? Because if I don't figure out the XY, I cannot really figure out overflow, which then I cannot figure out what is L. S is already done, okay, by the way, because S is just D0 in this case, it's already done. It's actually given to us. So how do I figure out the X and the Y at this point? Yes.
I was wondering if we're allowed to use discrete math operators instead of the M symbols or.
You can use any symbol that I understand. Yep. But you cannot, after the test, explain, that squiggly symbol over there, it actually meant blah, blah, okay? So if you're not sure, you can check with me, but since I'm also teaching 440, so all the symbols that I introduced in 440, you can use as well. Yes?
I was gonna say for the question, because Q0 equals 1,
Mhm.
that means that either X or Y, one of them has to be a 0 and one of them has to be a 1.
Yep.
And also because T1 is 0, it means that X and 0 have to be the 1.
Exactly. Exactly. So let me explain that in class. Your reasoning is 100%. But I do have to kind of write it out because the rest of the class probably wants to know what the answer is, right? So let me go back and look at which rule I need to quote. So it's going to be rule A. So I'm using rule A here. Okay. Okay, so let me just kind of pause here and see if everybody knows about the notation. So what this means is, now that we know Q0 is a 0, using rule A, we can now say, that implies X0 is different from Y0. Yes.
Yeah. Q0 is a
Oh,
one.
Q0 is a 1, right? Yep. There we go. Because otherwise, X0 and Y0 would be the same, not different. Okay, so because Q0 is a 1, using rule A, we can now say, we know the exclusive OR is a 1, which means the two sides of the exclusive OR, they have to be different. That is coming from a truth table, but I don't need you to quote the truth table and go through all that trouble. So, this will suffice. Is that okay? All right. All right, but how is that helping me? Because, we have two possible cases here. We can have X0 being a 1, Y0 being a 0, or we can have X0 being a 0 and Y0 being a 1. So who's going to come to the rescue and resolve which one is the case? T1, exactly. Because T1, okay. So now I say because T1 is already given to you as a 0, if X0 is 0 and Y0 is a 1, then T1 would have been a 1, leading to a contradiction. So, and I need to quote the rule as well. So the rule for the T bit is C. So according to rule C, T1 would have been a 1. So that means, this means X0 is a 0 and Y0 is going to be a 0. X0 is a 1, Y0 is a 0. Okay. So we have all the X, Y, Q, T, D all figured out at this point. So we just have to figure out the overflow, and then we can figure out the L. We are home free. Are we good so far? All right. Okay, so with those, we can always just go back to the definitions. Okay, so we'll go back to the definitions, and we'll start with the borrow flag. The borrow flag is easy. The borrow flag is really just T1 in this case, which is already given to you as 0. Okay, that's an easy one. Then the next easy one is the sign flag. The sign flag, by definition, is the most significant bit of the number, which in this case is D0. And we figure out D0 already, and it is, where is it? It's a 1. It's given. Oh, okay, right here. It's actually given to us. So that's an easy one too. Now we need to figure out the overflow. So the overflow equation, you don't even have to remember because I'm giving you that thing here, okay? So XS is the sign bit of X and YS is the sign bit of Y and so on. So now that we know X, Y, and D already, we just have to take a look at that pattern. All right, so what do we know? We know X is a 1, Y is a 0, D is a 0 as well because it's actually given to us. Is that right? No, it's a 1. So that means overflow is going to be a 0. So the correct way to, you can just do this, but then you also have to say because of the rule that defines that. So that would be rule D. Sorry?
I said delta.
Delta. Okay.
Yeah, for the rule,
Okay.
it should be.
Okay. That works. All right. So we only got one more, which is the L flag. So the L flag is according to, let's see which rule here. The L flag is E, right? So according to E, L is the sign flag, exclusive OR with the overflow flag, which in this case is 1, exclusive OR with 0, which is 1. So the L flag is a 1. It's all done. Now, I did write a lot more than, well, I shouldn't say a lot, but I wrote, it's more wordy than you have to do, okay? So what I'm really looking for are which rule did you apply, okay? And the reasoning and the conclusion for each step. Yep.
Do we need to include B? I don't see the test asking for B.
Yeah, B is. Yeah. Any questions about this particular? Yep.
I'm actually curious, maybe other people will disagree with, I'm wondering how you would write this like on paper. Like I wonder, is this a through typing? And then
I would just kind of write it the same way. I mean, you don't have to use as many words, okay? You can just, in this case here, instead of saying according to E, you can just say E implies L equals to S exclusive or OB equals to 1, exclusive or 0 equals to 1. So, a lot of the phrases in English you don't have to use, but you can use the mathematical symbols instead. Yep.
About single equals versus double equals.
Because double equal emphasizes that it is known to us at that point. The single equal means we're computing it. So I don't think I'm gonna make that much of a distinction with reading your answer. So we don't have to worry too much about the use of double equal versus the single equal.
Would it be okay if we were to have like maybe a table and like how you kind of showed us in last class, like our table and L.
Makes it more visual, right?
Yeah,
Yeah.
I think I would help from that. So.
Yeah. When you are working on your question, you can use whatever means on your piece of paper that helps you. So for some people, maybe they just need something like this. For some people, the visualization may be important. For some people, maybe it's important to draw arrows around. It's like, oh, these two going through this rule goes back to here, means this thing is this value. It's all okay. Yep.
You're stating like the contradictions, we don't need to do that on our test.
You have to rule out the possibility. So if there are two ways to proceed, you have to basically not only to confirm one way works, but you also have to exclude the other one cannot work. There was another hand. Yep.
We'll see the same as the I plus the XYI plus the EYI.
You look it up, right? So rule C is T of I plus 1 is basically B of XI, YI or B of QITI. So I'm doing you guys, I'm doing the class a favor here, just in case some people cannot remember what is B. This is how B looks like in binary subtraction. So we good so far? All right. Ready to move on to the next question of the same format, or do you want to skip over to the next type of question and then come back to this one when we have time? Skip over, okay, skip, not forever, but I want to expose you to the other question, which is base conversion. All right, but it's not exactly base conversion. Yep.
These are all subtraction, right?
Yes, because the question says, this is a 1-bit subtractor.
This is, oh, never mind this. Sorry.
Yeah. All right. So the first 4 questions are very similar in nature, and then we have questions 5 to 7, being similar in nature. So we'll go ahead and read the instructions first. These questions are about subtraction in base 6. Okay. So subtraction base 6. Very important to read the question. Bring a highlighter if you want to kind of like make sure that you remember what assumptions we can use. The specific values to subtract, add, X and Y are provided in each question. First, define R, F, G, and B, F, G. So in this case, F and G are just names of the parameters, okay? F and G have no specific meaning. I'm just using this and say, okay, tell me what is the expansion of R and G in base 6 in this case. Okay, so we'll get to that later. Answering this part correctly is a condition for the next part to be scored. So that means if people cannot answer this part here, I'm not going to score the rest because it is needed for the rest to make sense. You can answer this part here once instead of once for each specific question because all 3 questions ask you to do this. So you can just answer it once right here. All right, so let's go ahead and answer this one. What is the R of FG when we are dealing with base 6? Subtraction. It's important to emphasize it is subtraction because unless it is in base 2, the R's are different between addition and subtraction.
So it's gonna be the base plus F.
Right, base plus F, okay, and then
minus G,
mhm.
mod the base.
Yep, the whole thing mod the base. Very good. So let me go to Joplin and you'll kind of write that down first so that we have a representation of this. So this is for question, I think 5. So for question number 5, we want to define R of FG to be whatever the base is, which is 6, plus F minus G, and then the whole thing mod, actually this is better, mod 6, which is the base that we're dealing with. And that's how we define R. Do we have any questions about this one? All right. So I have to tell you, last semester, I think about half the class got this one wrong or missing entirely. I cannot even understand why that can happen. Because it is in the notes. I mean, it's all explained in the notes. All right, the next one is what about the B function? So BFG is, how is it defined? This one is even easier. Yep.
And X is less than Y, then.
There's no XY here.
If, F is less than D,
Mm-hmm.
then it evaluates out to 1, otherwise 0.
Yep, that's it. All right, because without these two, you cannot do the rest. Multi-digit addition does not work unless you understand how to perform each column, okay? And these 2 functions are necessary to compute the compute the P, the Q, because the R is used to compute the Q, and then the B is used to compute the T, and then for the D, we also need to use R again. So this is important, yep.
So if you asked specifically for R for mod 6, for base 6,
Mhm.
and then we gave that equation except for instead of 6 we put base, that would be wrong, correct? Because we didn't specify.
As long as it is clear, what base, I mean, if you just use the symbol B, for base, so instead of 6 here, you have B and then B over here, you might get a very minor deduction of points, but it's not going to be much unless you get all the calculations wrong, because that implies that you really do not know what base we're dealing with. All right. So now we can apply the actual calculation. So we switch back to the question here. And for this one, so we now need to read the questions, copy the following to your answer sheet, replace the question mark with the actual digits. So to answer your question, this is kind of like the visual way, right? You just copy the whole thing, and then you have to resolve the question marks. So we'll go ahead and do this. So control, screenshot this part, and then paste to here. All right. So I'm not gonna overwrite this part here because it's really difficult for me to reconstruct the table. So I'm just gonna work out the digits and just write out how each one is supposed to be. So we'll start with Q0. Oh, that's an easy one. Q0 is going to be a 0, so you don't have to explain anymore. Okay, so you can just work out the digits. So D0 is going to be a 0, okay? And then T1 is going to be a 0. Q1 is that's an easy one. Okay, so I don't want to, do all the fun stuff. I'll share the fun with you guys. What is Q1? Q1 goes here, it's just a 2, okay, so nothing to it for Q1. And then we can try to figure out what is D1. So D1 is really just a 2 because Q1 is a 2, T1 is a 0, 2 minus a 0 is a 2, regardless of the base. Okay, so this column is pretty easy. So column 2 starts to get a little bit dicey, but I wouldn't say it's too difficult because we already figure out the math. So D2 is what? If someone says 7, then that person is going to get double deduction of points because 7 cannot exist in a base 6 number. So not only was the calculation wrong, but it's also a reflection of a non-understanding of the concepts. All right, so 2 is less than 7, 2 is less than 5. Okay, we know that. So we know there's going to be a borrow, but we'll deal with that later. So what do we need to do when 2 is less than 5? We need to borrow. But every time we borrow, what is the quantity that we are borrowing from the next column? It's not 10 anymore because of the base, right? We're borrowing 6. So 2 plus 6 is an 8. 8 minus 5 is a 3. So D2 is a 3. There, okay. And then we also need to figure out what is T2. So let's go ahead and figure out T2. So T2, there are 2 chances for T2 to be a 1. The X, Y cannot explain it. And then now we need to look at the Q. So Q1 is a 0. T1 is also a 0. So there's no borrow to T2. So T2 is also a 0. And then we can now work out what is D2. D2 is basically 3 minus 0. No borrow is needed. So it's really just 3. And then we have one last digit to work out, which is T3. So T3 is a 1 in this case because 2 minus 5, the X minus Y is going to give us a borrow. So do we have any questions about this? I have to zoom out a little bit just so that you can see the entire thing.
So in our test, we can just rewrite that table.
Yeah.
And with all the numbers.
Yep, just instead of the question mark, you'll fill those in with the correct digits. And you don't have to explain that also. Just kind of do the computation and then write down the digits.
With answers?
Huh?
Just answers?
Just the answers in this case, yes.
And then also defining the R and B functions in 5, 6, and 7, those are all the same answers.
Yes. So once you define those ones, that's fine. I'll count those points in for all the questions. All right. So now we can answer the other 2 questions. What is the decimal representation of the value of the Q row? So now we need to figure out, okay, what is the Q row? So if you don't mind, I'm going to I will combine these into like fewer lines, just so that I have more lines left to explain the other ones. So the Q row is Q2, Q1, and Q0. So Q2 is a 3, Q1 is a 2, Q0 is a 0 in base 6. So this time I need you to explain to me, because I don't want someone just kind of whip out a super smart scientific calculator that has base 6 to base 10 conversion and just write out the answer. So you have to tell me, how do you figure out the answer? So this one is, the way I would do this, okay, then we use the mathematical notation because it just makes it easier to read. So we have 0 times the base raised to the power of 0 plus 2 times 6 raised to the power of 1 plus 3 times 6 raised to the power of 2 And that turns out to be 0 plus 2 times 6 is 12. And then 3 times 36 is 108, I think. And then when you do the addition, I think you get 120 in base 10. I think. You would think that I would write a calculator that can convert bases. I think that is the case. So is that okay?
Since the Q row is specified in the question, do we have to write Q row if we just?
No, you guys don't have to. Because in your case, it would be very visible already. The Q row is already staring at you in the face. But since I did not, fill in those question marks. So for my own benefit, I need to, remind myself, what does that row look like? All right, and then the last question is the decimal representation of the Y row. So now we just work on the Y row, okay, kind of the same deal. The Y row is already given to us, it's 5, 3, 4. So it's kind of the same thing. So that this time we have 4 times 6 to the power of 0 plus 3 times 6 to the power of 1 plus 5 times, 6 to the power of 2. All right, so that means we have a 4, we have 18, and then we have 180. And then when you add all of those up, I think it's 202. Mental math. So we good so far? So that basically completes the entire question. So questions 5, 6, and 7 have exactly the same format in this case. I don't think you guys want me to spend the time to finish up the other two because the procedures will be exactly the same. Yes.
You said there are a bunch of different variations of the test. Is it possible we could get ones on like 1 to 4, or instead of
No, they all have the same number of pages.
so no, but are they all subtract or could some?
They're all subtraction. Yep. Yeah, I really try my best to make sure all the variations have the same difficulty level. Are we good so far?
I know you don't want to call this a study guide, but like, how much do you think you can guarantee that this is kind of the test that we're gonna get on that Thursday?
Because I have not come up with the questions yet. So if someone were to say, okay, if a Vulcan is to mind map with me to try to get the answers of the questions for next Thursday, it would be blank. There's nothing there. Absolutely nothing. Yes. Okay, so I never give extra credit. What I do instead is I will take a look after the exam and see how the class did as a whole. Yes.
Now, do you have the test for this, for like exam 1 spring of like last year, like spring, like the test before this test?
I do have those. I actually keep all my tests, and so if you guys are interested, I can show you those too. Or we can do some of those during the lab time perhaps. So that's probably good use of the lab time, except most of you are thinking, but I want my really, really long weekend to be even longer and start now. Yes.
Just to make sure, this quiz will only cover.
No, not necessarily. We talked about addition, we talked about subtraction, we talked about base conversion. We talked about how values are represented by numbers. We talked about signed versus unsigned representation. I mean, this exam does not even touch signed versus unsigned. So the scope is this big, and I can only spot check certain portions of it. So which portion am I really going to test? Even I do not know because it has not happened. I know it is within this range. I just do not know which portion. It is a pretty big range, yes. Yep.
Do you know, will we
will this upcoming test have like 7 questions like this test did, or will it have?
I run on it.
No, okay.
Yep.
So definitions that you want us to include in our answers, we provided like A through E, the first 4.
Yeah.
Would there be any definitions we would have from like lectures that we'd have to write down just in case we for our answers?
You should always be prepared that you need to look up the definitions. So there are chances that I may not provide the actual definitions, because part of the test is really, I mean, the implicit part of scoring in my classes is knowledge is by default no, because it's open book and open notes. So you definitely want to be able to look up the definitions if you need to. Okay, now, in some cases, I might want to say, okay, I know this is going to be a lengthy test. I want to help you, kind of be more efficient with your time. So I'm going to give you the definition so you can just quote the definitions. So I might do that, but it's not a given that I will give you the rules or I will give you the definitions. You should always be prepared to look up the definitions from the modules, from the lectures, and so on. And this is why, from day one, I've been trying to encourage you guys to kind of put all the definitions at one spot, because then you would have your study guide already by this time. I know some of you are saying, so why didn't you say that was the study guide? I would have done that if you had told me that would have been the study guide. Yes.
If we have our own definitions, that doesn't give, we just like write them down on like our answer sheet or something in the letter room.
Yeah, that would be fine. Yep, that's perfectly okay. All right. Any other questions before I switch back to questions, 2, 3, and 4? Yep.
Can you send us the exams from the previous semester to the practice?
Yep, I can do that. Yep.
For the, I don't know if someone else said this, but for the practices, it appears that you need some of the codes for them to work. Is there a way we can,
There was only one. I think the 3x3 add, one of the 3x3 adder still had a access code. I removed that already. So they should all be without access code. And you can redo as many times as you want.
thank you very much.
Did you say today, in Mile, we're not doing the mechanical science today?
Yeah, there's no new material because we are basically, this is a review. All of this stuff we talked about already. It's just that the way they are applied is different compared to what we talked about in class. So there's no new material in here for the lab. So that's why lab is not mandatory today. But I will give you like an alternate version of this test. And for those of you who want to, okay, so if you are traumatized, do not blame me, but I can give you the exams from even earlier, from past semesters.
What solutions?
Yeah, I'll give you some of those solutions, sure. But the solutions are automatically generated, so it doesn't cost me anything.
Smart.
All right. So shall we go back to question number 2, 3, and 4? Okay, so let's go back. So what you really need to get out of today's lecture are the techniques. Okay, how do you start to think about the problem? How do you use whatever is given to you as a clue of how to proceed to answer those questions? Because you're almost guaranteed that the type of questions would not be the same as what you see today here. So it is the technique that matters. All right, so here's question number 2. So I'm going to take a shortcut method here. So instead of going through all the gibberish, all the writing and whatnot, instead I am just going to kind of use the approach that you mentioned. Use the graphical approach. All right, so this one, okay, I'm not sure anyone is on the Discord side. Let me check a little bit first. And nope, no one is on the Discord side today, which is weird. Let me check one more thing and I'll be back. I'll be right back. Yep, no one is on the chat side. So, okay, we're good. All right, so let me copy and paste the question first. And then switch to Joplin. There we go. All right. So I lied because, I can actually work out the columns. So let me see if I can do this. Okay, so we have the operator, and then we have an empty one, and then we have the column 1, and then we have column 0. Okay. And then, oops. There are 5, 4, 1, 2, 3, 4. There are 4 columns. Okay. So now I have to put in X is unknown. Okay. So this is unknown. This is a subtraction. This is Y0. It is known to be a 1. And then we have the Q's. The Q is unknown. None of the Q is known. And then we have none of the T is known. So here we have a subtractor thing. And then we have the D's. None of the D's is known. All right. So that's kind of the template. And then we have the extra stuff which are the flags. So we have L being 1 is given to you. Overflow is a 0 is also given to you. And that's it. So we have to figure out, okay, let me put a question mark where we need to figure out something. This we need to figure out. This we need to figure out. This we need to figure out. And this we need to figure out as well. Okay. Yeah, the yellow highlighted thing probably has to do with markdown, but I'm not too concerned about it. Let me just kind of quote that stuff too, so it doesn't interfere with the rendering. There we go. Okay, much better. Okay, so once again, the technique is, how do we get started? Well, we start with, on one hand, we have the definitions. On the other hand, we have things that have no values. So we want to match up the no value to be on the left-hand side of the equality, because that informs us about, what can I infer from this blah, blah, blah. Okay, so we got L, and we know L is the exclusive or between the overflow and the sign bit. So we know the sign bit already. Okay. So this time I'm not going to quote the rules, just as religiously as earlier. So this time this would not be an acceptable A answer, okay? But it will be kind of giving you a clue of how to do it. Okay, so I can say, okay, fine. I'm still going to quote the rules. So this is about L. So we are using rule E. Okay, so according to rule E, L equals 1, and that in return is defined as overflow, exclusive or with a sign bit, which is known as, one is known as a 0, and the other one is unknown, and this is 1. So this implies the sign flag is what? 1. It is different from the 0, right? So it has to be a 1. Does that make sense? Okay, so the sign flag is a 1. So that tells me that D0 sign is the same as D0. So, and that is now known as 1. All right. So I can now go back to where D0 is supposed to be and change that to a 1. Whew, okay, slight improvement there. Okay, so what else can we do at this point? So we know L is a 1. We know overflow is a 0. We know D0 is a 1. So what is the next thing we can figure out? Yes.
Using rule D, we can imply that X0 is
That's right.
0.
X
X0 is 0.
X0 is a It has to be a 1. Okay, so, okay, that's very good. It has to be a 1. Okay, so let me explain that. Okay, so we are using rule D, so that is very good. Rule D is very, very helpful. So we'll go back here and say using rule D. What do we know at this point? We know D0 is a 1. We know Y0 is also a 1. So if you look at rule D, we want the overflow to be a 0. So if X0 was a 0, overflow would have been a 1. So I'm going to explain it here, okay? So we'll say if X0 was a 0, then overflow would have been a 1. Therefore, X0 has to be a 1. And now I can go back to the table, update that to be a 1. Is that okay? So you were absolutely right to use that rule.
I did it right and then said.
That's okay, I do it all the time. That's why, I said if I was a student in my own class, I would not be an A student for sure. Probably a B student because I probably understand all the concept, but then I would make mistakes everywhere. All right, okay, so I think the natural third thing that we need to figure out is Q. We got X, we got Y. Q is like easy peasy. So going back to the rules, let's find out which one talks about Q. I think it's A. Yep, because I got that one wrong in the first place. So we'll say according to rule A, we already know X0 is a 1, Y0 is a 1. Therefore, Q0 is going to be a 0. All right, so we go back to the picture, update Q to be a 0, and we're almost done. So now we know that D0 is a 1. We know Q0 is a 0, so we need to figure out what is T0. So we'll look up the rule, say which one we need to use. So this time we are not using rule C. That is not what we use because we are going to use rule B. Okay, B is what we're going to use. So let me quote B here. So we'll say B. And what do we use other than the rule? We know that Q0 is a 0. We know that D0 is a 1. And therefore, T0 has to be a 1. Does that make sense? Yep.
I was gonna say, yeah, this method is much more followable. My mind is grasping a lot of
Which one?
this method.
Yeah. I mean, with a picture.
Yeah, yeah. I mean, it just makes it sort of you can see all the variables.
Yep. Yeah, so when you are doing it, you can use whatever representation works the best for you. And this is one nice thing about doing a test on paper, because if this is being done on Google Doc, okay, then you have to know how to, I mean, you can draw pictures and tables and stuff like that, but some people may not be familiar. But if this is on paper, you can scribble whatever you want. All right, so we are almost done. We only got one more thing to figure out, which is our T1, okay? And this is going to be using, I think it's rule C, but I can be wrong. Yep, rule C, okay? So now we say rule C. So we know X0 is a 1, Y0 is a 1, Q0 is a 0, T0 is a 1. And because of rule C, we now know that T1 has to be a 1 because we do have a situation of a borrow. So, and we put a 1 here. All done. So we good with number 2? Yep. Oh, this is 3? Okay. Go ahead.
This like weights the reasoning, whatever the points are this like perfect. And so the reasoning that you said that it wasn't as clear as the third one that we.
Yeah, it's fine. Yeah, I just did not use a lot of therefore, because of those things. But nonetheless, all the rules are here. And okay, so this is important. the sequencing of the application of the rules also makes sense. Okay, because in previous semesters, I would have some people going like, oh, I figure out this bit. It's like, how? All of these other things are still not figured out. What is the reasoning? No explanation whatsoever. That person just said, yeah, I know this bit has to be this. What?
Okay, so if we do have to go out of order, because like we hit the bottom of the page or something, should we number up and draw arrows?
Yeah, as long as I can understand, the sequencing, it's fine.
On step D, I lost, you. How did you get that Y0 1? How do you not know it? How do you know it's 1 and not 0? Which rule did you use to find that?
Okay, it's trying to figure out why
Y0 is given. This was given.
it's given.
Oh, there were 3 givens.
Yeah, so we can. So was it? Yep, go ahead.
So for this, so since it's one bit, we know that it's a one bit subtractor, we know that the overflow is the same as Q, right? Because the overflow has X and Y have to be opposite.
Overflow has to be, no. I don't think so.
Q is the more of X and Y. So if the overflow, if the overflow is 1, then Q is 1, right?
I do not know yet. Okay, that's okay. There were some other hands. Any other questions? Yep.
I was just, this I think kind of got explained, but I've taken the logic and critical reasoning class a couple semesters ago. And one of the things that we did was we numbered each one of our things, and then we would use that to relate back to, hey, because of this number plus this and that, we come to this conclusion. I was gonna ask on if that was okay, but I think that we kind of said yes because of the other.
Yep, that's perfectly fine. Yep, you can label, you can circle, you can like circle one conclusion, circle another conclusion, draw 2 arrows, combine it, and then put the name of the rule that you want to apply, and then put another arrow down as the conclusion. That works for me too, as long as I can make that connection of how you get to this conclusion and your reasoning is correct. You use the right rule and you're using the correct known facts at that time of the derivation, then you still get full credit. So I'm pretty flexible in terms of how you represent your reasoning, but I still need to see that reasoning in your answer. All righty. Shall we go for the last one? Or you guys kind of like totally pooped out and, yep.
I kind of want to see them to 2.
Number 2, I skip number 2.
This one.
Okay.
Yeah.
Okay, so let's go for number 2 because I totally skipped number 2. In this way, my son is very much like me. He skipped one entire page of some kind of assessment when he was in 4th grade. He came home and go like, Dad, it's okay. I know the answers. I know the material. It's okay. Yes, there was a hand somewhere. Yep, go ahead.
I'll say, didn't take roll as well.
I'm not gonna take roll today because we got something far more interesting to do. This is like a shiny object to me, solving puzzles.
Shiny object.
Did I tell you guys that I enjoy debugging, especially when it's somebody else's program?
I love printing out the output as well.
No. No CL statements, use GDB. All right, so this one says, we only know T0 and we only know overflow. Okay, so this one is interesting because overflow is very informative. Okay, knowing overflow to begin with can be a huge help. Okay, because to know overflow means you can sort of figure out one of 2 scenarios, and each scenario tells you about 3 bits. Because you need X, Y, and D. And there are only 2 ways to combine those 3 bits to be a 1. Now, if overflow is a 0, it's not quite as useful, still useful, but not as useful as in this case. Okay, so let's go ahead and work this out. And I'll just be a lazy person and copy and paste this portion here. So how many lines do I need to copy? 7. And then do a paste. I like how Joplin can understand VI key binding. So this way I can just reuse all the key binding that I have known already. So we don't know anything about this one. Nothing about this one. We do know this is a 1. We don't know, oh, we know this one is a 1. We don't know anything about this one. Nothing about this one. Nothing about this one. And then the L flag is unknown. The overflow is a 1. Oh, I need to do a code block here. All right. And but the sign bit is unknown as well. Okay. Okay, so this is really cool. So how do we proceed with this one? Once again, the same rule. Okay, you always start with the definitions and what is known to you. Yes.
Overflow, it can either be 100 or 011.
Yep. So you can put one in and see if it fits, and then put the other one and see if it fits. Okay, so let's go ahead and try to do that. All right, so we'll start with okay, we'll put it here. So overflow. So we'll quote the rule, which is I think is D, but I can be wrong. Yep, it is D. So according to D, overflow is given to be a 1, means x0 is a 0, y0 is a 1, d0 is a 1, or x0 is a 1, y0 is a 0, d0 is a 0. Okay, does that make sense? It has to be one of these two, okay? So what we do is we just try both out, okay, and see how they work out. So we'll say, we'll call this one case A, and we'll call the other one case B. So this way I can just refer to the case and not have to, repeat everything here. Okay, so we'll work out case A first. So under case A, so this time it's a little bit harder to do it here because then I have to go back and erase stuff potentially. So I'm just going to work out the math here. So in this case, Q0. Okay, do you guys still want me to quote the rule? Yep. Oh, okay. So we'll go ahead and go back to the rules. A, okay. So according to A, Q0 is going to be a 1. In fact, both of them will have Q0 being a 1. So I can now case B is kind of the same thing. Using rule A, Q0 also has to be a 1. But then D0 would have been different, okay? And that is going to help us. So we'll say in D0, in this case, would have been a 0. And that is according to, I think it's the second one, which is rule B. Yep. So, oops, according to rule B, D0 would be a 0 in this case. And in this case, D0 would have been a 1. Okay, let me think. Q0. That would have been the 0 too. Okay, that is already enough. Okay, so this is already enough to tell me which case is going to be ruled out. Okay, so why can I stop right now and say, I know which case has to be the right one and which one has to be the wrong? How can I tell?
The first one is, it says 1 exclusive or 1 is 1, which is wrong.
Oh. I'm not sure what you mean by that.
It says,
Okay, go ahead.
Isn't it because 1 counteracts itself? So because the second piece of case A is D0 equals 0, and at the original overflow, D0 is equivalent to 1 in case A.
Yep.
That cancels itself out. and then
It leads to a contradiction.
Yeah.
Yep. Okay, so let me, you got your hand up too.
Just double checking, is case 1A and case B? Are they the same?
No, because case A means, I'm assuming x0 is a 0, y0 is a 1, d0 is a 1. Case B is x0 being 1, y0 being a 0, d0 being a 0. So those are the only ways to make overflow a 1. The only thing that we are given with is overflow is a 1 and t0. Okay? But one of them has a contradiction, because in the case of case A, this is what I'm assuming, but because of the way we compute d0, it ends up to be a 0. So that means that cannot be the case. So what we do here is to say, but this contradicts d0 being a 0 in the assumption. So now we can rule out case A. So case B is the good one, because in case B, d0 is 0 in the assumption, but it is also ending up as a 0 as we went through the computation. So after that, we can actually update the table, because now we can say we got a 1 here, we got a 0 here, we have a 1 here, we have a 0 over here. I know we are running out of time, so I'm not going to quote the rule name here. Can we figure out this guy now? Yeah. So do we have a borrow? Nope. So this is going to be a 0. So what else do we need to figure out? We need to figure out the L flag. Okay, what is the sign flag? It's D0, which is a 0. So the L flag is the overflow exclusive or with the sign, which is a 1. Done. Now, the last part, I did not quite spell out the reasoning or the rules, but it was fairly straightforward at that point. There's no tricky application of logic anymore. Okay, so what is the takeaway? Because you guys have a little bit earlier about the study guide. Yes.
Plug it in. If I plug it in.
Again?
I could have figured that out.
Yeah, but you can do whatever you want on your piece of paper. And if you look at a section of the reason and go like, oh no, that's totally wrong. Just put a big cross. Don't use an eraser and try to erase everything. You can just cross it all out. And I understand. Okay, do not read that part. Is that okay? So just go for efficiency. Okay, it doesn't have to be pretty.
So for the first 4 questions, you wanted us to find anything? For the first 4 questions, you wanted us to find everything. SL, everything. So
That's what the question is asking. Read the question. Okay, that's it. That is optional. Whoever shows up in the last questions, I will try to answer those questions if I can. Not in this case. Not in this case. In this case, T0 is a draw. So, okay, so this is good. Without this, so what I will do is you have time and correctly. Yeah. So you're gonna have the present center. The DSPS. Yeah, you can just bear. So yeah, and I will finish the rest of the because I have to send them so that they know that they expect to get to. Okay. There are no rules here. They have a reason. I get it. It's not multiplied.
This four. X.
Oh, yeah.
Okay, what looks like multiplication is conjunction, what looks like addition is disjunction, and then the exclamation point is negation. This X or it is doing the same thing as exclusive or. Yes,
this
according to the
or-
left.
This same X core equality for. What's this whole, the X or.
It is doing the purpose R of X, Y, Z to exclusive.
I compare this and this.
Was that case?
What different? Different this.
This is a or, this is a regular.
This or as this. X core.
I never use exclusive or anyway. There's no exclusive or operator in the derivative.
This.
It serves the same purpose as exclusive or, yes.
Except what formula it's for.
It serves the same purpose as exclusive or, yes.
То есть, так вот, is this X core, this core.
This is regular or, that is exclusive or.
No, так, different, this equality this.
Yes.
This.
Yeah, these are all equal, these are all the same.
Okay, то есть, is this, значит, this equality this.
According to the derivation, yes. Yes.
This or this X
You
core.
can interpret it any way you want, but I can only tell you that every single row are the same. But we need the last row in order for the,
Yes.
in order for carry look ahead to work. If you put an exclusive or in place of the or, it is not going to work.
Так, а this это this equality this.
No, exclusive or is not by default the same as regular or. It is just that in this case, they turn out to be the same, yes.
Not this equality, this equality, this.
Yes,
equality,
they
this
are equal,
equality.
yes, that's what the equal sign means, right?
This equality, this,
Yes,
yes.
Yeah.
This same,
yes,
K same,
yes,
different only. Square.
but without the derivation in between, how can you tell?
This needs same, this needs same, this needs same.
Yes,
Так, this or,
yes, that is regular or.
as this X.
That would be the same as exclusive or, but I did not use the exclusive or operator. Are you
To
asking me
prove-
why we?
Proof exclusive or equality.
No, 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 no,
This
no.
formula.
No, only in this scenario, only in this case, that exclusive or turned out to be the same as the regular or. But in general, exclusive or and or are not the same.
Oh, no, okay.
It is not a proof that or
Okay,
and
fine.
exclusive or are the same. It is just that in this case, in this particular application of how we combine the X and the Y in this particular way, that exclusive or and the or turned out to give us exactly the same result. So I would not say in general, exclusive or and or are the same. I would say in this particular case, they turn out to be the same. Okay. So that's good observation, but it does not mean the proof is not, does not have a point.